Hey, this is Pragya Shaha, and today we are going to talk about another mineral exploration book, but this is just geophysical exploration. So, here is the book. This is Geophysics for the Mineral Exploration for the Geoscientists. This is by Stephen T. Mudge and Michael Dennith. So, let's see the contents of the book. We have introduction, the physical versus chemical characterization of the geological environment, geophysical methods in exploration and mining. So here there we get the airborne, ground and in-ground surveys, geophysical methods and mineral deposits, cost of geophysics, geophysical data acquisition, processing and interpretation. Introduction, types of geophysical measurement, absolute and relative measurements, scalars and vectors, gradients, nature of geophysical responses. Signal and noise, environmental noise, methodological noise, survey objectives, geological mapping, anomaly detection, anomaly definition, data acquisition, sampling and analyzing system footprints, survey design, feature detection, data processing, reduction of data, interpolation of data, merging of data sets, enhancement of data, data display, types of data presentation, image processing, data interpretation general, interpretation fundamentals, removing the regional response, data interpretation, qualitative analysis, spatial analysis of 2D data, geophysical image to geological map, data interpretation, quantitative analysis, geophysical model of the subsurface, forward and reverse inverse modeling strategy, non uniqueness, gravity and magnetic methods, introduction, gravity and magnetic fields, mass and gravity, gravity anomalies, magnetism and magnetic fields, magnetic anomalies, measurement of the earth's gravity field, measuring relative gravity, measuring gravity gradients, gravity survey practice, reduction of gravity data, velocity effect, tidal effect, instrumental drift, variations in gravity due to Earth's rotation and shape, variation in gravity due to height and topography, survey summary of gravity data reduction, example of the reduction of ground gravity data, measurement of the earth's magnetic field, geomagnetic field, measuring magnetic field strength, magnetic surveys practice, reduction of magnetic data. Then we have temporal variations in field strength, regional variations in field strength, terrace clearance effects, leveling, example of the reduction of aeromagnetic data, enhancement and display of gravity and magnetic data. See, this is a very detailed book, so it's going to be long. I am sorry if you are bored. Oh, choice of enhancements, reduction to pole and pseudo gravity transforms, wavelength filters, gradients or derivatives, density in the geological environment, density of low porosity rocks, density of porous rocks, density of lithology, changes in density due to metamorphism and alteration, density of the near surface, density of mineralized environments, measuring density, analysis of density data, magnetism in the geological environment, magnetic mineral properties of minerals, rocks, igneous rocks, sedimentary, metamorphosed, altered rocks, near surface, mineralized environments, magnetic property measurements and their analysis, correlation between density and magnetism, interpretation of magnetic and gravity data, gravity and magnetic anomalies and their sources, analysis of gravity and magnetic maps, interpretation, interpretation pitfalls, estimating depth to source, modeling source geometry, modeling pitfalls, examples of gravity and magnetic data. I'm sorry, I'm distracted. I'm suddenly reminded of some chatter, banter. I banter with a lot of friends and I remember the banters all day long. So now, interpretation of gravity and magnetic data, gravity and magnetic anomalies and their sources, analysis of gravity and magnetic maps, interpretation pitfalls, estimating depth to source, modeling source geometry, Modeling pitfalls. Examples of gravity and magnetic data from mineralized terrains. Regional removal and gravity mapping of paleochannels hosting placer gold. Modeling the magnetic response associated with the Wallaby gold deposit. Magnetic responses from an Archean granitoid greenstone terrain, Kirkland Lake area. Magnetic responses in a Phanerozoic orogenic terrain, Lackland Fold Belt. I am looking so pretty now. Magnetic and gravity responses from mineralized environments. Finally, we are going to read radiometric method, and radiometric method is extremely important for BARC AMD. Okay, so BARC AMD examination questions. Hashtag radiometric survey. Radiometric method. Introduction. Radioactivity, radioactive decay, half-life and equilibrium. Interaction of radiation and matter. Measurement units. Sources of radioactivity in the natural environment. Measurement of radioactivity in the field, statistical noise radiation detectors, survey practice, reduction of radiometric data, instrument effects, random noise, background radiation, atmospheric radon, channel interaction, height attenuation, analytical calibration, enhancement and display of radiometric data, single channel displays, multi-channel ternary displays, channel ratios, multivariant methods, radio elements in the geological environment, disequilibrium in the geological environment, potassium, uranium, and thorium in igneous rocks, potassium, uranium, and thorium in altered and metamorphosed rocks, potassium, uranium, and thorium in sedimentary rocks, superficial processes, and potassium, uranium, and thorium in the overburden, potassium, uranium, and thorium in mineralized environment. Interpretation of radiometric data, interpretation procedure, interpretation pitfalls. Then we have responses. Okay, responses of mineralized environments, examples of geological mapping in a fold and thrust belt. There is Flinders Ranges, interpretation of gamma logs. Then the summary review questions further. Reading. Electrical and electromagnetic methods, electricity and magnetism. There is fundamentals of electricity, fundamentals of electromagnetism, electromagnetic waves. Kitna lamba hai yaar. Oh god. Electrical properties of the natural environment, conductivity or resistivity, polarization, dielectric properties, properties of the near surface, measurement of electrical and electromagnetic phenomena, electrodes, electrical and electromagnetic noise, self-potential method, sources of natural electrical potentials, measurement of self-potential, display and interpretation of SP data, examples of SP data from mineral deposits, resistivity and induced polarization methods, electric fields and currents in the subsurface, resistivity, induced polarization, measurement of resistivity or IP, resistivity or IP survey practice, display, interpretation and examples of resistivity or IP data, interpretation pitfalls, resistivity or IP logging, applied potential, miscellaneous method, then electromagnetic methods and principles of electromagnetic surveying, subsurface conductivity and EM responses, acquisition of EM data, processing and display of EM data, interpretation of EM data, interpretation pitfalls, examples of EM data from mineral deposits, downhole electromagnetic surveying, acquisition of DHEM data, display and interpretation of DHEM data, examples of DHEM responses from mineral deposits, induction logging, airborne electromagnetic surveying, acquisition of AEM data, AEM subsystems, AEM survey practice, display and interpretation of AEM data, examples of AEM data from mineralized terrains. Then seismic method. We have introduction, seismic waves, elasticity and seismic velocity, body waves, surface waves, propagation of body waves through the subsurface, wave fronts and rays, Fresnel volume, seismic attenuation, elastic effects of elastic property discontinuities, acquisition and display of seismic data, seismic sources, seismic detectors displaying seismic data, seismic reflection method, data acquisition, data processing, variations in seismic properties in the geological environment, seismic properties of common rock types, effects of temperature and pressure, effects of metamorphism, alteration and deformation, seismic properties of mineralization, seismic properties of near surface environments, Anisotropy, absorption, summary of geological controls on seismic properties, measuring seismic properties, interpretation of seismic reflection data, resolution, quantitative interpretation, interpretation pitfalls, examples of seismic reflection data from mineralized terrains, in-seam and downhole seismic surveys, in-seam surveys, tomographic surveys. So it was the detailed geophysical exploration I have ever read. The index. So yeah, this is one of the great books. It's colored. The most beautiful fact is this is a colored book. The paper quality is really nice. This is hardcover. Hardcover, that's the bad part. I don't like hardcover. It becomes heavy. Whenever it gets a hardcover, it becomes heavy. But this is one of the best books for BARC AMD. If you have to appear for the exam, you have to go through this book. So yeah, I love this book, and there are many more books to come. Hope you like this video, enjoyed this video. See you in the next video. Until then, ta-ta.